Good morning, girls. How are you? Let's continue with chapter 5 dynamics. Today we will talk about inclines or inclined plane surfaces. Inclined problems are a special case where the x and y axes are not useful. It is easier to work with tilted axes that are parallel and perpendicular to the incline. Look here, this is an incline. What does it mean? It's not a horizontal surface, it is a tilted surface or a surface with an angle. Okay, this is incline. What we have to do in inclined planes? Now, before, if this box is here down, it's so easy to resolve or to know the forces acting on the box. You say that normal force toward up on the y-axis, force of gravity toward down also on the y-axis, to the right, for example, the applied force on the x-axis, and to the left, friction force on the x-axis. But in this case, the x-axis, the y-axis is here, vertical. The x-axis is here. So they are not helpful or useful. We have to find another way. What do? We assume that this line that is perpendicular to the surface is the x-axis, and you want to tilt the x and y axis. You want to tilt the x and y axis. How? Just draw a vertical line perpendicular to the tilted surface or inclined surface. This one we call it y-axis. Then we draw another one parallel to the surface. We call it what? X-axis. Then we continue solving. Why we want to do this? Because we know that always the normal force, it is what? It is on the y-axis because it's perpendicular to the surface. So in this case, normal force, no need to resolve it into two components. There will be no angle between the normal force and the y-axis. It's exactly on the y-axis. That's why we tell the axis. The second thing we have is what? Force of gravity. Now here, force of gravity will not be on the y-axis, okay? It is in between the x and y-axis. Why? Because force of gravity, it is the force that starts from the center of the object vertically toward down in a straight line. It's not perpendicular to surface or something. It is what? Vertically toward down. It has to be perpendicular to the earth. Okay, surface of earth. That's why FG. So girls, always in an inclined plane, the first step you have to do is to draw the two axes, y and x axis. After that, you will draw the forces on the axis. Normal force here exactly, and FG, it's always between the x and y axis. After that, you have to resolve which one. For sure, normal force, I will not resolve it. No need, no angle. FG, there is an angle. Always the angle that is here of the surface, it is the same as this angle that is here. If this one is 30, here it is 30. So easy to resolve. What do? We say that FG perpendicular or FGY equals to FG, this one, cosine this angle. Remember sine and cosine? And this one, FG sine the angle. Okay, this is what we have to do. The force of gravity must be split into components. Solving the vector components of the force of gravity results in the following equations. As I said, force of gravity parallel to the incline, it is FG sine theta. FG, what does it mean? Force of gravity equals mass times 9.81 times sine theta. And FG perpendicular, M times G times cosine theta. Okay, here's the rule. It is a rule, a law. Try to remember it and don't forget it. Okay, always for inclined plane. Let's solve this example together to make sure that everything is clear. Okay. Look here, please. First of all, Now, as I said, inclined plane. Here's the inclined plane, inclined surface. Here's the angle. The first step, draw the y and x axis. Here's the y perpendicular to the surface and x parallel to the surface. Then remember to write the two formulas. Let's read the question together and to solve it. A 5 kilogram mass, so I have mass equals 5 kilogram, is positioned on a 30-degree angle, so angle equals 30. It is kept stationary. Remember, I told you before, when you read this word in any question, what has to come to your mind? Newton first law, that sum of forces equals 0, from the word stationary. Okay, good. By a string, it means that we have tension force, but it is not given. Pulling parallel to the incline, determine the tension in the string. They want you to find the tension in the string, and this is a picture of the question. M only, and I have here a line. The first step, what you have to do? Who knows? You have to draw the two axes here. I will draw this axis and the other axis, y and x, perpendicular and parallel. Okay, after that I will draw the forces, all forces around the object. We said normal force always here, force of gravity always here, and I have here in this question tension force, it is here toward up. Okay, so how can I find the tension force? Tension force, it is what? On the x-axis. What is the other force here on the x-axis? Fg, because Fg, I will resolve it into two components. Remember the rule here. Fg, here is the first one, it is Fg sine theta, and this one Fg cosine theta. That's what I have to do. Okay, after that I will look at Newton's first law. I write sum of forces equals 0 on the x-axis. We are talking, I don't care about the y-axis, okay, because they're asking for tension and tension is on the x-axis. Sum of forces on the x equals 0. What forces I have? Tension, and it's positive because it's going toward up, so tension minus what? Fg sine theta, what equals 0. Tension is unknown, minus Fg. How to find Fg? It is mass times g times sine theta equals 0. Again, tension minus mass is 5, g is 9.81 times sine, angle is given, it is 30. Let's find the answer. 5 times 9.81 times sine 30. The answer is tension equals 24.5 Newton. This is the final answer. This is how we solve inclined plane questions. Always, girls, always we solve it this way. Okay, sometimes if they ask for normal force, what you have to do in this case, you write sum of forces on the y-axis equals 0, normal force minus Fg cosine theta equals 0, and so on. Okay, this is how we solve it.